Good afternoon, everyone. Welcome to yet another webinar in the webinar series 2024 of Moldex 3D on the topic of using simulation to optimize injection molding cycle time. Outline for today, we'll have a brief introduction to cycle time and followed by optimizing the filling, packing, and cooling time, and how we'll show how do we go about doing that using Moldex 3D simulation. So injection molding cycle is made up of four main sections: filling time, packing time, cooling, and all the rest. That includes mold opening, ejection, mold closing, screw moving forward, and so on. Majority of the cycle time comprises of cooling time, but we will look at optimizing filling, packing, as well as the cooling time. So filling, how do we go? We will look at shear heating balancing, shear heating and cooling, and balancing of which effect dominates the flow. We will compare and understand the impact of the two and understand how to use that to optimize the filling time, although it is a very small portion of the total cycle nonetheless. Next, packing and holding time will determine how to determine the gate freezing time in the Moldex 3D Studio. In cooling, which happens to be the chunk of the time, we'll look at how to use the time to eject result in Moldex 3D. The last one here, mold opening time, it is more on the physical process side of the equation, where how much time it will take to open the mold, how much time it will take for the part to be ejected, to drop into the container, and so on. So those aspects we will leave out of the equation for today. So how do we go about optimizing filling time? Let's look at the traditional way of using the U-curve theory, where you start with a very low injection time and you see that your required injection pressure to fill the part is on the higher side, and then as the injection time is increased, you can see that the injection pressure requirement keeps lowering down until it reaches a lower plateau, and then after that it starts increasing. Now increasing again, and this happens because initially there is a lot of material that is being pushed into the cavity in a very small amount of time. So there's a lot of back pressure that is being pushed. There's a pushback from the material. So that's why the pressure requirements are on the higher side.